So hello friends, welcome again, and today we are going to solve a new question, and this question is construct binary tree from pre-order and in-order traversal. So this is the question for today, and in this question what we have to do is that we have been given the two traversal of a binary tree. First is pre-order and second is in-order, and we have to construct a binary tree using this two traversal. So in this example, here you can see that we have been given a pre-order. That means the root node of the pre-order, root node of in-order, and we have to construct the complete tree. So that's what we have to do. Now let's understand how we can approach this question and solve this. So here you can see that in the first example that we already have two values. First is pre-order and in-order. So these are the collection or the storage of the all the node values in the pre-order and the in-order manner. Now using these values we need to construct a binary tree. Now we have used or the question has given us pre-order and in-order. So it is a question that why we cannot use other DFS approach which is post order. So why cannot we construct a binary using pre-order and post order? So we have three types of traversal. First is pre-order, second is post order, and third is in order. Now if you clearly see that what is in order, so it is means that first we go to left, then we come to the root node, and then we go to right. In post order, what we do, we first go to left, then right, then root. And in pre-order, we first take the root, then go left, and then go right. So you already know that what are the functions of these three algorithms or approaches. Now it is important that there is only one there is only one traversal in which you can directly get the root of the binary tree, which is pre-order. So in the pre-order you can directly get the root at its first position. So here you can see that 3 is going to be our root. So this is an important part because that's why in every case you need pre-order. In place of in order you can use post order, it doesn't matter, but pre-order is important to get the root of the binary tree at the first position. So here you can see that if you are able to get the root of the binary tree. Now let's move forward. Now let's think about how we can solve this. So if you get the root node, now what is left to us? So we if you get the root of a binary root of a tree, now the part which left is the left part and the right part. Now you need to construct these two parts. Now what we need to do is that we need to find the values which are in the left side and the values in the right side. So that's why what we can simply do is that we can simply call recursive calls. So simply what it means that you create the root node and you call a recursion to create its left part and its right part. Now to call a recursion for left and right part, you also need the pre-order and in-order for its left and for its right. You understand? Now in pre-order, how you can get the part which is on the left. So if you are getting the root node at 3, now what you need to do is you need to find the that 3 node or 3 value in order. And it is given that all the values are unique, so you can simply find out there is no duplicate or there is no 2 3 in order. So there is going to be unique 3. So if you are able to find the 3, then it is important that all the values which are before 3 are going to be for the left part and all the values on the right of it is going to be the right part. Why is that? Because in order means left, root, right. That means the root is in between the left part and the right part. Now you know that the left part is this and the right part is this. You can simply provide these values to its recursive calls. That means 9 to the left part and the rest of the values, that means 15, 15, 20, and 7 to its right part. So this is going to be in order for its left and right. Now the left part is pre-order. Now what we do with pre-order. So the first node is used, which is 3. Now you can simply, what we can do is that we can take the size of the left or right. It depends on you. So what we can do, we can take the size of the left. Here you can see the size is 1. So if the size is 1, that means the pre-order also contains only one value. So what is going to be the pre-order for the left part? It is going to be the node which is just next to 3. And why is that? Because you already know that pre-order is going to be root, left, then right. What it means that 3 is your root. Then the part which is coming next to 3 is going to be its left part. So you need to get the values from just next nodes from the 3. So you are going to pass 9 to it. So there are, these are the two values. That means these are the two different values. First is going to be your pre-order and second is going to be in order for the recursive call, which is going to give us a binary tree for the left part. Similarly, you already have constructed your in order, which is 15, 20, and 7, which is the right part. And for the pre-order, now you have extracted the pre-order for the left. Now the remaining part, which is 20, 15, and 7, is going to be the going to be the pre-order for the right part. Now for the right part also you are have got the in order and pre-order. Now you can simply call the recursion for the right part also to construct and give me a binary tree. So how you can simply write it? So you can simply write in the main function, what you can do, you can simply write your root value equals to 3, and what you can do, you can call root left and you can call root right. Okay, left and right. So what it is going to do, it is going to construct and provide such as a binary tree, because every time it is going to do the same, and every time we are providing its pre-order and in order. So you have clearly understood what is the approach which we are going to follow. Now let's code it. Now let's start the coding part, and let's take the root node, and the root node is going to be root node is going to be tree node. And let's take tree node star equals to root, and it is going to be new node, and we are going to take tree, and the value it is going to take the, so the root is going to take the value at the first position in the pre-order. So it is going to be pre-order 0. Now after this we have two value two work we have to do. We have to call the recursive function for left and for the right. Before that, we need to find the value of the root node in the in order. And why it is important? In order to find the upcoming or the pre-order and the in order for both left and right. So firstly, we are going to take int equals to 0. And after this, we are going to run a while loop. And in this while loop, we are going to check a condition, which is going to be until our pre-order, until our pre-order 0, which is our root value, is not equals to our in order I. So we are checking our value, which is a root node value in the in order, and until we are not getting this, we are increasing our I. Now after this, what we have got the position where we are getting the root node in the in order. It is important because all the values before it is going to be our part of left part, and all the values next to it is going to be of the right part. Now it is also helpful in other cases. Now let's see. Now simply what we have to do is that we have to call the recursive function for both left and right. So let's first start with the left part. So for the left part, it is important to check first that there may be case that there is no node in the left. So for that, when the case arises, when your root node, which is the this 3, which is your root value, is present at the first position in the in order. What it means, there is no root value node before it. So that means it is going to be null. So we have to check that condition that it should not arise. So if our I is greater than 0, then we are going to call, and if it is not, then we can simply leave it as it is, because it is already null. So next what we have to do, we have to slice the vector which is pre-order and in order for left part. So we are going to update our pre-order in order vector for left and right. So it is the idea. Now let's take a vector. So this is the vector, and it is going to be our pre-order for the left. So we are going to name it as PL. Similarly, we are going to create we are going to create another vector which is going to be your IL, which is going to in order. Now let's slice the vector. So we have pre-order. So let's start with the pre-order. So we have to pre-order dot begin. So let's see where we have to start our slicing. Now in the pre-order for our left part, we have to leave first node because it is the root node, and the value next to it is going to be the left part until its size. That means what is the size of the left part is important, because here in example you can see that if you use this while loop, what is the value of I you will get? You will get 1 because it is at this position. But it means that the size of the left part is 1 because there is only one node before it. So using this, you can simply say that the one node after the root node is going to be the node for the left part. So we are what we can do, we can start your begin from preorder dot begin plus 1. We have skipped the root node, and we have skipped the root node. Next we have started our taking the nodes for the left part, and until we have to do, so we can simply copy this. So we have to do until, we have to first skip our root node, and we have to also skip the size which is I. So what we have done, we have started from the value which is next to the root node, and we have taken all the values until its size has completed, that means 1. So it is going to take 9 only. Similarly we are going to do uh, for the our in order also. So let's copy the same code, and let's copy in order and paste here. Now let's see. So in order, we have to start from the beginning. That means it is going to start from the beginning, and until we have to do until I, because we need only one node. So we are going to do we are going to move until one position. Now next what we have to do. So what we have to do is that we have to call the left part. That means recursive call for the left part. So we write root left is equals to our build tree, and what are the values it is going to get, it is going to get the two vectors which is going to be pl comma il. Okay, now this is completion for the left part. Now let's move on to the right part. So for the right part also, similarly the condition which we have checked, that means root should not be at the starting position in the in order. Similarly, if the root is present at the end position in the in order, that means there is no node on the right side. So we have to check that. So if our I is less than, we can take any value. So we are taking preorder dot size minus 1. So if it is less than the preorder dot size minus 1, that is if it is before the last position, we have to do this unless we leave it. So let's copy all the code from here, and now let's see. So here first update the name, it is going to be for the right, so name it prpi, sorry prir. Now here you can see that how we are going to do this. So for the right part in the pre-order, you can see that right part is going to be the position, right part is going to be the values which is after we have taken the values for the left. So first we have skipped the value for the root, then we have skipped the value for the left. Here I is the length of the values which existed in the left part, and until we what which position we have to take the values, so we have to take the position end. So until the last part we are going to take all the values. Similarly for the in order, you can see that first what we need to do, we need to skip all the values for the left. We skipped using plus I, and we have to skip the value for the root which is 1. So we have skipped for the root. Now in the in order, we have to stop it until end, similarly the as we have done in the pre-order. So this is the complete slicing of the both pre-order and in order for the right part. Now let's call for the right part. Now we have to build, and we have to simply update this to pr and ir. So this is the complete code. We have created the root, call the recursive function for left and right by updating its pre-order and in order. Now let's simply return your root. Now let's run this code. So this is accepted. Now let's submit this. So this is accepted. So this is the question for today, and I assume you have understood it very clearly. Now you are going to see the solution for both Java and Python in the same video. So stay tuned, and let's meet in the next video with a very interesting question which is also related to the tree part. Till then, keep learning and exploring, and keep tuned to our YouTube channel. Thank you all.